Lesson 2 Extra Practice, Video 2. Use the formula for population growth to predict the population of each city. So we're going to use our continuous growth formula, which is PERT. P is your principal amount. So in this case, since we're not talking about money, we're going to talk about the initial population. R is your rate as a decimal. T is the time in years. So on number 1, we have a starting year of 2016, and then we want to know the predicted population for 2025. So basically 25 minus 16 is going to get us our T value, our number of years, so 9 years. So I have A of 9 equals, and then the initial population is this number here, and then E is E. Rate as a decimal is 0.029, so 0.029, and then T we said was going to be 9 because it's 9 years to go from 2016 to 2025. So we should just type this all in and get our answer. And there should be an E button on your calculator, just a matter of finding it. If you can't find it, it might be under the math button. You could always Google whatever version of a calculator you're using and ask where the E button is if you can't find it, because all calculators have it located in slightly different places. Now I'm talking population, so I'm going to round to the nearest whole number. So I have a 0.3, so I'm just going to keep it to 2. So there is our predicted population for 2025. For number 2, our rate is 1.8, so as a decimal, that's 0.018. The population in 2013 is approximately 636,500 people. We want to know what it'll be in 2025. So 25 minus 13 is 12, so T is going to be 12 for 12 years. So A of T equals our initial population times E to the rate written as a decimal, so 0.018, and T we decided was 12. So we're just going to type this in. And then I get approximately 78996. And then it's a 0.6, so I'm going to round that up to 2. So about 789,962 people. On number 3, in 2013, we have a population of 775,000, annual growth rate of 3.2%, which is 0.032 when we write it as a decimal. And then what is an approximation of Sharp population in 2000? So on this one, we have to kind of go backwards. So 2000, the year 2000 minus 2013, that's actually going to be a negative T value because we're going back in time. So I'll do A of negative 13 equals our initial value times E. The rate is written as a decimal. And then our T value, we're going to do negative 13 since we're trying to figure out what the population was in 2000. Okay, so I'm getting, let's see if this answer actually makes sense. I think it will. And it was a 0.2, so I'm just going to leave it the same as opposed to rounding up. So, let's see. Does that make sense? 252,000. So this number is smaller than the amount that they gave us in the problem, which again, that should make sense to us because now we're saying in the year 2000, the population was about 511,252 people, and then it grew to about 775,000 in 2013. So that makes sense to us that this number is actually smaller than the starting number they gave us. In number 4, in 2012, here's our initial population. Our annual rate is 5.5%, so as a decimal, that's 0.055. And then we want to know what the population was back in 1980. So if I do 1980 minus 2012, that's going to get me my t-value, which is negative 32. So we'll do a of negative 32 equals the initial value, that big number, 2690,000. Our rate is always written as a decimal, so 0.055, and our t-value is negative 32. Type that in to the calculator. So I'm getting a nice big number here. So this number is definitely smaller than the original number, which makes sense because we're saying that in 1980, the population was 3,559,608 people, and then it grew to 20,690,000 in 2012. So that answer should make sense to us. So in number 5, we'll notice that our rate, our percentage is 0.75. So that is showing us that we're decreasing because, hold on just a second.